We are pleased to introduce you to our upcycled vertical macroalgae cultivation project by Team Aloha Limu. From the Big Island of Hawaii, this majestic island is known for its pristine waters, active volcanoes, cascading waterfalls, and powerful surf. Located on the east side of the Big Island, our project was initiated at the Pacific Aquaculture and Coastal Resources Center in Hilo. This center is a hub for aquaculture enthusiasts, academics, and serves as an educational institute through the University of Hawaii. The star of the show is the macroalgae Halymenia hawaiiana, known in Hawaii as limu lepe o hina. We source the macroalgae for each of our 5 trials from these 3 stock tanks, which we culture at the pack rack. In our macroalgae lab, we have trials initiated in flasks, our commercial salad spinner and heavy-duty scale, and the macroalgae for our trials, soaking in germanium dioxide to inhibit diatom growth prior to inoculating our bags. Our concept was born by utilizing old microalgae culture cages and unused bags from the microalgae culture production on site. We restored an oyster fattening system site for our project. This involved laying new PVC pipe and cleaning the system, as you see Lauren testing the lines for bleach. Here we have Lauren and our esteemed professor and mentor, Karla McDermid, talking strategy. Our deep seawater well serves as our primary water source. Our bags have ports for air, water, and an overflow, constantly circulating seawater through each bag. Here Lauren and I are installing everything for trial 1. The manifold distributes air evenly throughout the system to ensure proper circulation and aeration. The 360-degree design allows for maximum and evenly distributed light exposure to all of the bags. We then add 560 grams of Halymenia per bag. Now, isn't that beautiful? We used F/2 fertilizer as a supplement, as our seawater is not very mineral rich. The process of adding supplemental nutrients caused excessive diatom growth, although this did not affect the quality of the Halymenia or inhibit its growth to a large extent. Our first system used seawater, which was filtered through ultra filters, cartridge filters, and UV prior to use. But we decided to go to Plan B and use an existing out-of-service microalgae system to compare results. Here's Lauren preparing the system to be cleaned prior to use. This system proved to have similar results, although for this trial we compared fertilized versus unfertilized bags. Diatom growth was slower in the unfertilized bags. Due to the diatom growth, we did not experiment with recycling the seawater from the overflow back into the bags. Our harvest method was efficient, although we were not able to reuse the bags since we cut them at the bottom for harvest. The Halymenia looked beautiful for each of our 5 trials, and we had various growth rates over each 3-week trial period, with some bags reaching over 1 kilo of growth in just 3 weeks. We'll try another approach and mix our own fertilizer, which excludes silica. This should help minimize diatom growth. We also experimented growing Halymenia in 4,000-liter conical tanks to further compare results. Overall, our vertical bag experiment went exceptionally well, and we had successful and increased growth rates throughout our 5 trials. The concentration of F/2 nutrient supplementation at 38 milliliters per bag was the most effective in increasing growth for commercial scale. Here are some of the products we made, including dehydrating and creating flake and powdered Halymenia, mock-up labels for product development, and a futuristic AI perspective into how this project could be implemented at a large scale. The goal is to have macroalgae growing in even arid regions of the world. Thank you for this amazing opportunity, and we hope to continue on to phase 2 so we can continue to grow and scale macroalgae production in Hawaii and beyond our shores. Aloha limu from the Big Island of Hawaii.